So, nodal analysis. Why do we need to do the nodal analysis? If there is more than one source in a circuit, for sure you cannot solve a circuit by using either series parallel combination method or star delta or delta star method. So here we are solving the circuit by using nodal analysis. In reality, I mean, say for example, if you have your home is connected with solar panels and a grid or a utility company, so you have two sources. One is energy is coming from the utility company, another one is energy is coming from the solar panels. Okay, so this circuit replicate like that. Okay. Now, to do the nodal analysis, first thing, find all the nodes in the circuit. Node is nothing but a point where two or more elements connected. Okay, so here I have node 1, node 2, node 3, and node 4. And take one of the node as a reference node. We'll take that reference node voltage as 0. Because in any electrical circuit, always one of the node voltage is going to be 0. One of the node is going to be grounded, so ground value is 0. So we always take a ground voltage as 0. Do I need to choose the bottom one as reference node? Need not to be. You can choose any one of those 4 as a reference. But to be consistent with the textbook, I'm choosing the bottom one as a reference node. Okay? And that makes it a little bit easier. Most of the cases, you will end up having more elements connected to the bottom node. So you will end up with less equations in less portion of equations in one equation. So I would go with bottom as reference node. Now, so that's a step 3. Now step 4, apply KCL at each node if needed to find that node voltage. My goal in this problem is finding I1, but now I shifted my goal of finding V1, V2, V3 instead of I or I1, because once you find V1, V2, V3, now I can find either current or voltage or power in any one of those elements. So now my goal is shifted to finding V1, V2, V3. Now apply KCL at each node if needed to find the node voltage. So if we look at node 1 at V1, okay, so we know that V1 minus V4 equal to 20 volts. So V1 minus 0 equal to 20 volts. V1 must be 20 volts. So at node 1, you don't need to apply KCL. KCL is Kirchhoff's law. I'll talk about it in a second. So here, if we have a voltage source between a reference node and unknown node, then that unknown node voltage is equal to the source voltage. Okay, so we don't need to apply KCL at that point. So node 1, we don't need to apply KCL. Node 2, for sure, there is no voltage source between V2 and V reference, so we need to apply KCL there. Okay. So here it is at V2, I'm trying to apply KCL. So I have IA, IB, IC, all currents are going out. KCL is nothing but Kirchhoff's current law. So currents coming in must be equals to currents going out, or all the currents going in or going out or coming in must be equal to 0. So I'm choosing all the currents are going out, IA plus IB plus IC equal to 0. So IA is nothing but, I is nothing but Ohm's law. According to Ohm's law, I equal to V over R. Okay, so I can write it as VAB over R, which is VA minus VB over R. By using the principle IA, I can write it as V2 minus V1 over 15. Why it is V2 minus V1, why not V1 minus V2? Because current always flows from higher potential to lower potential. I'm choosing I1, I'm choosing IA is flowing from V2 to V1, so it must be, V2 must be higher potential than V1, so I will write it down as V2 minus V1 over 15. And IB equal to V2 minus 0 over 20. Excuse me. and I see V2 minus V3 over 5 must be equal to 0. Okay, and solve. I'm multiplying this with the common factor 60, make it as a simple equation. I also substituted V1 equal to 20 in that equation, so I end up with a nice equation, 2 unknowns, 1 equation. Same way at V3, apply KCL. So at V3, I have 4 elements connected. So I1 plus I2 plus I3 plus I4 equal to 0. So I1 equal to V3 minus V2 over 5. I2 equal to I2 equal to V3 minus V1 over 10. I3 equal to V3 minus 0 over 25. I4 equal to negative 5. Okay, we always write it down I4 as V3 minus 0 over 5. That's wrong, because I already know I4 equal to, I know in this branch current is flowing I4, but I already know there is negative 5 amperes flowing in that branch. Or I4 and 5 amperes in opposite direction, so take I4 equal to negative 5. So that's the fourth equation. I'll end up with the nice equation. So 2 unknowns, 2 equations. Solve those two to find V2 and V3. Start. Okay, so we have 2 unknowns, 2 equations. So I solve those 2 unknowns and 2 equations here. There are so many methods: substitution method or cancellation method. So here, I multiplied equation 1 with 10, which is the constant coefficient of V2, and the second equation, and the second equation with 19, which is coefficient of first equation. Okay, so I cancelled V2, end up finding V3 equal 36.69 volts, and substitute V3 value in one of those 2 equations to find V2. So I end up V2 equal to 27.38, V3 equal to 36.69. So now I know each and every node voltage in that circuit. Once I have the node voltages, now my goal is finding I. I'm trying to find I here. So I substituted I equal to, I'm assuming I equal to I1 plus, I equal to I1 plus I2. Now I1 equal to V1 minus V3 over 10, I2 equal to V1 minus V2 over 15. So substituting those values, I end up a negative number, negative 2.16 amperes. That's the total current. So that negative indicates that that source is not supplying any energy. Instead of supplying, it is taking energy. It's just like you have solar panels in your home. So this is like a solar panels, and that's a grid. So solar panels are generating more energy. You're supplying it back to the grid. You're selling the energy basically. Okay, that's all. Thank you.